G'day, Jay here, and this video we'll look at basic Perlin noise. Just calling on the Perlin noise at a specific position and getting its exact value. So you can map out something that you see quite often here when you see Perlin noise. It's like basic Perlin. Okay, before I do, I didn't quite explain why I iterated through Y first and then the X. Now, through all that confusion, as I said, set pixels takes a one-dimensional array. That's why we iterate through this loop here and create that. Now, the pixels here in the one-dimensional array are ordered as such. It goes along the X first, and then it goes along the Y. So that's what this loop is doing. So we loop through all the X's first. So it goes X, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then when we get to the end of the row of X, then we jump up a column with the Y. So it's like Y0, X, 1, 2, 3, 4, 5, 6. Then we go Y1, X2, and that orders that one-dimensional array in what Unity is expecting it to be. So again, to summarize, we go the X first and then the Y. That's why that loop runs inside first. And then we jump a Y, or X, Y. Okay, enough explaining. So the basic Perlin. Where do we start? So this Perlin map kind of goes on indefinitely. So we need to define a scale, an amount of Perlin which we're going to be reading from. Now I'm going to be calling this frequency. Now, it might not be the correct technical term, but that's what I'm going to be going with here. So noise type, let's create another set of variables. And make a public float frequency. This will all come clear once we hit play. Equals, let's just start at 1, so we can see what one cycle of Perlin looks like. Alright, so how do we get this value of Perlin? Okay, so we're doing basic Perlin, so we're going to be editing basic Perlin. So let's start. I'm going to create a noise float. My keyboard's sensitive there. Let's just say equals 0. Okay, so as you can see from all these diagrams, Perlin noise is like a 2D map of values, and what you see in all these examples is exactly what we're doing. We're taking this float value and we're turning it into a color and putting it onto something you see. So the black is equal to 0, the white is equal to 1, the grey is in between. So where on this map are we going to be asking for what that float value of noise is? So we'll create a float. Our noise at position X. And where is this position? Well, we'll take X over the texture size to give us a percentage of where we are in that frequency. So let's convert this to float. Float X divided by float texture size. Okay, so that'll give a percentage value between 0 and 1, and then multiply that by the frequency. And the same for the position Y, because Perlin's 2D, so that's float Y of texture size times frequency. And then we need to evaluate that. So our noise float will equal mathf.Perlin noise at these float positions that we just calculated here. So nx, ny. And we'll return that. Okay. So let's see what we've done here. Just rename the scene. Everything's the same here. So we've got our noise type enum. We're at basic Perlin at a frequency of 1. So let's hit play and see what we get. Not much. Okay, that's a very small sample of Perlin. Now, if we change the frequency to 2, press the mouse button in the scene, we see we're starting to see more of that Perlin map. So double that, go 4, and now we're starting to see a larger range. So you can imagine the frequency like it's the wavelength. So we've got a 1 wave here, 2 waves, 3 waves, 4 waves. So as we keep increasing the frequency, we get a large map. And now we're starting to see something like you see normally in all these depictions of Perlin noise. When you start getting to a crazy size, it starts to become non-coherent. Even though it is in its surface level, the sample we're taking from is so large, the frequency, that it starts to become noisy and eventually washes itself out. So yeah, that's basic Perlin in a nutshell. So next, we'll look at these cloudy images, the fractal Browning motion.